Hello friends, let us see the next question on the prime number. Now, we want to find if a given number is prime number or not. Now, we know that 1 is neither prime nor composite. Now, the prime number range is from 2 till infinity. There is a theorem to find if a number is prime or not. The least prime factor of a number is always less than or equal to the square root of the given number. Now, what do I mean? Say for example, we want to find if 37 is prime or not. That means, yes, 37 is prime, we know that. We need to find, is there any factor for 37? The first option is, you may try from 2 till 36. You say 2, 3, 4, 5, so on up till 36. Why we start from 2? Because 1 is divisible by each and every number, and the prime number says a number which is divisible by 1 and itself. Therefore, we do not take 1, neither we take the number itself. The in between 2 and 36. Now, if the number is n, if any number is n, how many possible things you will try to divide? It is n minus 1 possible things you will try to divide. Now, this is a huge thing. If I take n as 1000, that means you will try to divide 999 numbers. I am just taking 1000 order wherever the prime number is there. Now, you check, is 2 divides 37? No. 3 divides 37? No. 4 divides 37? No. And so on up to 36 divides 37? No. That means it is taking n minus 1 possibilities. This is option 1. Let's try about the option 2. Now, what is the option 2? We know that if I divide this number by 2, 37 divided by 2, integer by integer is integer. It is 18. Like even if I take 19, 19 into 2 is 38. That means if I chuck till n by 2, that is still 18, and if I find any factor which is dividing 37, then I can be sure that this is not a prime number. Therefore, we say 2, 3, so on up to 18, and this takes n divided by 2 steps. Now, this is also a large. Now, if we use this theorem, that is the option 3, now what is the square root of 37? Square root of 37 is 6 point something. But we take only the integral part and we take all the numbers from 2 to square root of the given number. That is 2, 3, 4, 5, 6. Does 37 have any factor between 2 to 6? No. Therefore, 37 is a prime number. That is what it says. The least prime factor should be available between 2 to square root of the given number. Therefore, this option is being better over the other two. Other two will work, but they are slower. This is faster. Now, let us take for example, we take n is equal to say 47. Now, what is square root of 47? Again, it is 6 point something. Therefore, you have to take it from 2, 3, 4, 5, 6. We make a set of this. Does any number from this set divide 47? No. Therefore, 47 is a prime number. Now, if I take for example n is equal to 45, which is not a prime number. Again, square root of 45 is 6 point something, 2, 3, 4, 5, 6. Does any number from this set divide 45? Yes, there are two numbers. One is 3, one is 5. Therefore, 45 is not a prime number. That is what we do. The least prime factor of a number is less than or equal to the square root of the given number. Let us see how do we write a program to find if the number is prime or not prime. Let us see how do we write the program for this. We read a number n. Suppose the number n is 17. Now we want to find 17 is prime or not. Now what we need to do, we need to form a set from 2 to square root of the number, that is 2, 3, 4, because square root of 17 is 4 point something. Now this set starts from 2 and goes up to the square root of the number. Hence we write here for I starts from 2 and I goes up to square root of the number n, and you can say I plus plus, because why we say I plus plus, you can see the common difference of this set is 1. Actually, we have to take only the prime numbers, but that we will see in the sieve algorithm when we study the arrays. Okay. Now I is 2, square root of 17 is nothing but 4. 2 less than or equal to 4? Yes, 2 is less than or equal to 4. Now check, is 17 is divisible by 2 or not? Because the value of I is 2. Now you have to check if n modulo I, 17 modulo 2 is equal 0. You need to check it. If it is equal to 0, what to do? We will say it. 17 modulo 2 equal to 0? No. That means 2 is not a factor. 3 may be a factor. Try it. I plus plus, I becomes 3. 3 less than or equal to 4? Yes. 17 modulo 3 equal to 0? No. That means 3 is not a factor. 4 may be a factor. Try it. I plus plus 4. 4 less than or equal to 4? Yes. 17 modulo 4 equal to 0? No. Therefore, this is also not a factor. We say I plus plus, I is 5. 5 less than or equal to 4 is false. Is that okay? Now, why we are coming out of this loop? Why we are coming out of this loop? We are coming out of this loop because this condition has failed. Because this condition has failed. This is the first scenario. Now let us take the second scenario. I say n is equal to 9. Let me say n equal to 9. Now what is square root of 9? Square root of 9 is 3. That means it is 2 and 3. Now I starts from 2. 2 less than or equal to 3. Yes. 9 modulo 2 equal to 0. No. You say I plus plus, the value of I will become 3. 3 less than or equal to 3. Yes. 9 modulo 3 equal to 0. Yes. That means you have found a factor 3. Suppose there were some more factors. Okay, let me take, suppose n was say 15. Okay, n is 9. Suppose there were some more factors. Do I need to check other factors? No. If I find at least one factor, it is not a prime number. Say for example, if I take n equal to 21, square root of 21 is 2, 3, 4. It is 4 point something. Therefore, it starts from 2. Hence, we say I is equal to 2. 21 modulo 2 equal to 0. No, 2 is not a factor. 3 might be a factor. You say I plus plus 3. 3 less than or equal to 4. Yes. 21 modulo 3 is equal to 0. Yes, it is equal to 0. It means you have found 3 as a factor of 21. Do I need to check the other factors? No. Because if it has any factor between 2 to square root of number, it is not a prime number. And if it is not a prime number, why I go on doing it to prove that it is a prime number? It's a waste of time. Therefore, what do we say? We say break. There is no point in continuing further. Now, what does this break will do? Break will come out of the loop immediately. Break will come out of the loop immediately. And for the second time, you came out of the loop because of break. First time you came out of the loop because of this condition has failed. Second time you came out of the loop because of this break. Now when you come out of the loop, you should know why did you come out of the loop. Either this condition has failed or you reached the break. Why we need to know? Because if I know that I came out of the loop because of break, it is not a prime number. If I know that I came out of the loop because of this condition, that means it is a prime number. There should be some mechanism to know. And how do we know? We can use a help of some variable, and we can take the help of some variable called as flag. You can rename anything. Normally we take as flag. Why we take as flag? Say for example in wars, if two parties want to continue the war, they show some color flag. If they want peace, they show some other color flag. Is that okay? Now if in our country there is some national mourning, the flag will be half raised. If I say the flag is half raised, I can know that it is some national mourning is there. If the flag is full raised, there is no national mourning. That means you can see the flag and can decide on the condition. Similarly, we take the variable name from there. We use the variable name as flag. You can use any other variable name. You can use X, Y, Z or something. And I say flag is equal to 0 initially. Now, what do I say? If flag is lowered, for me, it is a prime number. If flag is lowered, for me, it is a prime number. And if flag is raised means 1, for me, it is not a prime number. Therefore, what do we say over here? If it is not a prime number, flag should be raised. And when we come out of this, we check the flag. If flag is equal 0, printf prime number, else it is not a prime number. This is where we end. Now let us trace it and understand it How does it work? Now say for example I say n is equal to 8. Now 8 is not a prime number. Square root of 8 is nothing but 2 point something. It is 2 itself. Now we start I from 2. And what is the initial value of flag? The initial value of flag is equal to 0. Now 2 less than or equal to 2, yes. 8 modulo 2 equal 0. Yes, 8 modulo 2 is equal 0. You raise the flag saying that it is not a prime number. You say flag equal to 1. Come out of it, 1 equal 0, no, and it say not a prime number. Now let us say n is equal to 7 and initially the value of flag is 0 again. I is 2, square root of 7 is 2. 7 modulo 2 is equal 0. No, do not execute this. Execute I plus plus, the value of I becomes 3. 3 less than or equal to 2 is false. That means you are coming out because of this condition. You come out, the value of flag remains 0. 0 equal 0, yes, and you say it's a prime number. Right? That's a simple thing to know how do we find a number is prime or not. Please like this video, subscribe this to my channel and share this channel with your friends. Please write in the comment section about how you find the explanation and the video. Thank you friends for watching this, and this prime number is used mostly in information security algorithms like RSA, okay, and all those algorithms we will use the prime numbers. Thank you once again for watching this video.
For the online paid courses of C programming, data structures using C, and analysis and design of algorithms, you may contact at the given email ID and you may download the following app. The app link is being given in the description section. Thank you.